Hey everyone, welcome back. We're going to go through the last two SQL injection challenges on this website, on the Portswigger Labs. The reason why it's sort of taken so long to get this video out was sort of two reasons. One, I've had a lot of personal things going on, and secondly, it requires a Burp professional license in order to hit the collaborator servers. The reason why I kind of was umming and ahhing whether to actually make this video or not was because I wanted to make this series as sort of free as possible, so you didn't need the professional license to go and sort of do the other challenges. However, we need to hit the collaborator servers, and I don't believe that you can do that without Burp Professional. So there's a couple of things I want to show you. There is a, I suppose, cheat sheet from Portswigger, so let's look for that. Portswigger SQL Injection cheat sheet. And the reason why I'm showing you this is because this is sort of, I'm not sure which one it is. Oh, this is sort of the only way of not the only way of solving this. This is the way that I would look at this and solve it. So let's go back to the challenge and we'll sort of read through it and see what we have to do. So this lab contains a blind SQL injection vulnerability. The application uses tracking cookies for analytics and performs a SQL query containing the value of the submitted cookie. The SQL query is executed asynchronously and has no effect on the application's response. However, you can trigger an out-of-band interaction with an external domain to solve the SQL injection vulnerability. To solve the lab, exploit the SQL injection vulnerability to cause a DNS lookup for a Burp collaborator server. That's fine. That's not a problem. So let's load up the lab, and I'll grab the URL and chuck it in Burp when it's loaded. So on my laptop, which is my work laptop, I do have Burp Pro. Let me just pull that up. Right, okay, so I've got the Burp collaborator server running. Unfortunately, I can't really show you it because, like I say, it's on my work laptop. So I'm just going to, I'll take a screenshot of the interactions as they come in, and then I'll sort of add them to the screen once it's done. So let's get started. Okay, I've opened this website in the wrong browser, but that's fine. Let's open up the Burp browser, and then I don't have to deal with the SSL certificate. And we scroll down. Oh, close that. We scroll down to find the SQL injection one that we're looking at, which is this one here. So let's access the lab. We know it's already. Oh, there's the SQL injection cheat sheet anyway. So that's perfect. Let's access the lab, and we'll grab we'll view the details, and we'll turn intercept back on. We'll move this out of the way a little bit. Move that to one side and move this to the other so we can see what's going on. So we'll intercept this. Let's refresh this page and we can see the tracking ID here. So let's send this to repeater. And now we have it. So if we send this off, we know that we're not going to get we'll get a response back, but it's not going to be different per sort of application or anything like that. Cool. Okay, so what we want to do is scroll down in the cheat sheet, and somewhere you'll find an out-of-band sort of section. Where we're looking, DNS lookup. So this is what we're trying to do. And there's a few different options here. We've got Oracle, obviously Microsoft, and Postgres, and MySQL. However, we don't know which one it is. So we can try a few different things. Let's grab this. So this is the first payload that we're going to try. We're going to try the Oracle one, and it's just going to be almost a sort of copy and paste of this. So let's bring up our notes again. Nope, it's just a text editor, isn't it? Let's scroll in to make it a bit bigger. So what this is doing is it's sort of making the database think that we're trying to do a XML parse. It's part of an external XML entity attack, and we'll cover these off in later videos, I'm sure. But basically what happens is you make the system perform a HTTP request, and you get the response from that through the third-party sort of domain, in this case, Burp Collaborator. So let me grab my Burp Collaborator server, and we can just chuck it in here straight away. And I always like to give something, like give a path for this. So I'm going to do something like subscribe to Mantis. This just shows that it's hitting the exact path that we wanted rather than just hitting the root domain or just doing a DNS lookup, although we do get a sort of indication whether it's DNS or HTTP. But either way, this is what we're going to do. Now, what we actually also need to do is we need to, because of the way that we did it in the previous episodes and the way that Oracle works, what we want to do is a string concatenation. So we're going to do an apostrophe to close off the previous statement. Then we concatenate our string, and then we want to do a sub-select here, like that. And then we also want to add that bit in. So again, I'm just going to sort of show you what this looks like. So we select everything from analytics, where analytics ID is equal to the one that we have up here. And then we do this. So we... Actually, that's not quite right. So let me just clarify this. That is what the query probably looks like, right? So our injection point is within this quote. So we paste our payload in there, and you can sort of see that it clears everything up. So we've closed off the quotes. So we closed off this quote here, and now we're doing a concatenation. We're selecting that. And then we also want to concatenate the rest of whatever else was there. So what we need to do is just copy this and chuck this in here and see if this works. And again, we need to URL encode this just because of the spaces and sort of the special characters. Okay, I can see that it has actually worked. I have got a HTTP request from the collaborator server on my laptop. I'll put that on screen now so you can see it. I will show you an example of both the DNS request and the HTTP request that came in. So there is the DNS request, and there is the HTTP request. Now, all that's done is it did the external XML entity attack through the SQL injection, and it hit our collaborator server. Now, I don't know what the next challenge is, but I imagine it's going to be something along the lines of exfiltrating data from this attack. And what we'd need to do then is select something into this remote thing here, and then we can either we can probably append it to the URL, or we can do something like that. So that's going to be it for this lab. Thank you for watching, and I will be back soon with the final SQL injection video. Thank you.